I'm Logan Harris.
And we decided to do our presentation on experiment 7, which was determination of the concentration of a weak acid. Alright, so basically what we're doing with this is we're trying to standardize a solution of NaOH. In other words, trying to find the concentration of this. And the process that we use to do this is the process of titration. And we also used KHP and a phenolphthalein indicator to do so. After this was done, later in the lab, Hogan will tell you we found out the standardization of another acid, an unknown acid. Okay, so the experimental, we prepared NaOH, 250 milliliters. We put this NaOH into a burette that would be used for the titration process. 4 samples were made using a solid KHP between 0.3 and 0.4 grams. Those masses will end up making a difference in our results because just how much is in there will affect the overall concentration. 100 milliliters of distilled water was also added to the flask with the KHP and was used to dissolve the KHP. Then 2 drops of phenolphthalein indicator were put in. These were used to show the reaction had occurred through a change of color. And the NaOH in the burette was dropped in until the solution changed to a pink color. That's when we knew that the reaction had occurred. First we did a rough trial, and then we did 3 others just to see if we could find like an average result. So the reaction here, NaOH and that long KHC8H4OH, that's actually just the KHP, formed water and KHP's conjugate base, which is NaKCH4O4. The NaOH just reacts with the KHP, and that's what comes from it. So here we have our calculations from the reaction. The mass of KHP was 0.368 grams, and the volume of NaOH stated there is 21 milliliters. So 21 milliliters was put into liters. I think that's a typo right there. That should be 0.0210. Because you have to put it in liters to find the molarity. So the mass of KHP was multiplied by the molar mass, and that helped us find the complete molar mass of the KHP in the solution, which came out to be 0.087, so that's the molarity. Our average, because we had different amounts of KHP in our solutions, was a little higher than that, and it deviated by 1.08 and -2, so just a little bit of difference between our results.
Alright, and for the second part of our experiment, we were taking the standardized solution of the NaOH and finding an unknown concentration of acetic acid. We used this standardized solution of the NaOH in order to find the concentration. Right here is our equation, which is NaOH plus the acetic acid forms water plus acetic acid's conjugate base and a excess of Na or sodium. The NaOH reacts with unknown acetic acid to produce water, and like I said, the base and sodium. Right, some of our calculations, just one of them was 15 milliliters were added of the NaOH, and the volume of the unknown was at 100 milliliters. So we took the volume of the NaOH and multiplied it by our volume of the unknown in order to get our molarity of the unknown acid. Our average came out to be a little bit lower than our molarity on this one, and our deviation ended up being 1.06 times 10 to the negative 3. Right. Our reaction continued, as you can see in our graphs. Each time we started at an initial Biuret reading of 0 milliliters, just to make it easy on ourselves. We're doing the calculations. Each time it ended up being a little bit different on the ending of the final Biuret reading, but it was pretty close, all the same. Alright, and then our results. The molarity of the NaOH ended up being at about 0.087 molarity. The unknown concentration of acetic acid ended up being at about 0.149 or 0.15, depending on how you round it, molarity. One of the questions in our discussion table, or on our discussion questions, was why did we use KHP? And we use KHP to standardize NaOH because the NaOH does absorb the water from the air around it, and the KHP helps it to not absorb as much water from the air around it, making it much more accurate in our weights of the NaOH. And there are the references.